Hello students, in this video we'll determine if a series converges if the series is summed over a subset of the natural numbers and not just the natural numbers themselves. Let's be more specific. Let's let S be the set of all natural numbers that have no two consecutive digits in a row that are the same. And equal, okay? So in other words, let's do some examples of these things. So what would an example of something like this be? So for example, the number 1, 2, 1, 2, 3 would be in what? Would be an S. If I just do 1, 2, 3, that's going to be an S. 1, 2, 3 is an S because there's no two digits that are the same in a row. But 1, 2, 2 is not an S because there's two 2's in a row, okay? Great. So now here's the question. Does the series, the sum over n belonging to this set S of 1 over n converge? Okay. Now typically you might be thinking, wow, this is going to diverge because it looks like the harmonic series. So note this looks like the harmonic series. Note this looks like the harmonic series. The sum n goes from 1 to infinity of 1 over n, which is divergent. But the key here is I'm not summing over all of n, right? It's very much akin to saying something similar to this. I'll give you an example when it would clearly converge. Consider R to be the set of what? To be the set of all n squared, such that n is in n. Okay? Then, what is this? Then the sum of n and r of 1 over n, you might say, well, is that going to converge or not? Well, what are the only n's you're summing over? You're summing over the squares over here. So this would be the sum. K goes from 1 to infinity of what? Of 1 over k squared. And we know that converges, right? So if we restrict to a subset of n, there's a chance that we might get convergence, right? So what I'm doing is I'm just summing over different sets might make the these harmonic numbers over here converge, right? And that's the question we're asked here. So let's figure that out. So how are we going to figure that out? Well, let's do it. We're going to partition the problem. So partition S. Okay, how am I going to do that? I'm going to let Sk be the number, be the portion, is a subset of S consisting of the k digit numbers in S, right? Then S, this implies that S is the union, k goes from 1 to infinity of Sk, okay? Well, how many one-digit numbers are in S? Well, all of them, right? They're all in S. So S1 is just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's fine. Don't really care. I can throw that number out. That won't affect the convergences at all. Let's look at Sk in general. So what would Sk look like in general? What's the cardinality of Sk? Cardinality, let's count. In other words, how many elements are in Sk? Okay, let's think. So we have k digits. There's k of those things. I have how many choices for the first digit? The first digit can't be 0, so I can have 1 up to 9, so there's 9 choices for this. Then I could have what? I could have 0 through 9 over here, but it can't repeat. So whatever number is over here can't be over here, so that's another 9 choices. The same thing over here, there's 9 choices for this. There's 9 choices for this, right? So there's a total of the cardinality of Sk is 9 to the power k. Great, okay? And so now, but if n, so what I can do is I can say therefore that the sum of n and S, 1 over n, is equal to the sum, k goes from 1 to infinity, of the sum over n in Sk. Okay, so I sum over all these Sk of 1 over n. Okay? Now here's where I can estimate. If you're an SK, you're a k-digit number, right? I can make a k-digit number smaller, which would increase this sum by making the denominator smaller itself, right? So I can replace a k-digit number with a simple k-1 digit number, right? So this is less than or equal to the sum. K goes from 1 to infinity. And then I'm going to replace this. This is no more than just the sum over n and k, n and sk, of 1 over 10 to the k-1. That's a k-1 digit number that's bigger, that's smaller than all of them. That makes the whole sum bigger, right? And so now what? So now I can replace this with the cardinality of the size of that sum. So this is equal to the sum. K goes from 1 to infinity of what? Of just 9 to the k over 10 to the k, and I'll pull the 10 out because it's in the denominator. Now this is a geometric progression, right? This is 10 times 9 over 10 minus 1 minus 9 over 10. And this is just going to give me 90, which is less than infinity. So our series converges by comparison. Hence our series converges by direct comparison. So in other words, by excluding the numbers that have 2 digits in a row, that gives me enough to make this harmonic series with a restriction converge, right? So it goes to show you that oftentimes in these problems, re-indexing or partitioning a set that you're summing over is a very, very useful mechanism for determining convergence of an infinite series. Thank you very much.